So I'm glad to be here today, and I didn't really recognize myself in that wonderful introduction, but here I am. So let's get started here. So this starts back in 2001, which everybody knows is a very important year. I had just gotten back to work at that point. And I was not a graduate student. You know, there's a myth everything was done by graduate students. I wasn't one at the time. I worked for a Space Dynamics Laboratory that's up in Logan, Utah. And I was an oddball there, right? But I reported directly to the president of that company. And I had a good deal of freedom to fool around, which is one of the reasons I ended up in Python. So I ran Linux, Python, and Numeric at that time, and only one other person in the company used those tools, and he had come over from JPL. So what was Python like at that time? 1.5 was still widely used. Python 2 came out in 2000. Python 2.1 came out in 2001. And there was a wonderful document for that. That was Python Essential Reference by David Beasley. And when it came out, it was about half an inch thick. That was the first edition. The third edition was about that thick, about double the size. So Python was already growing pretty fast back then. But that was a wonderful little reference which told you how to use Python and how to write extensions in C. That latter is important. And Numeric at that time was actually in pretty good shape for what it was. It was well documented. Again, that's important because it's almost like the NumPy user guide came out of that. And all the early people there have their name on it: Asher, Dubois, Conrad Henson, and Jim Huguenin. Huguenin is usually given credit for starting Numeric. And it was pretty good. It was missing a bit. The random package for it was very basic, and it was also buggy. One of my first fixes was to that package. Unfortunately, there was no central repository, so that bug kept coming back with every new commit. It was sort of really the cockroach of bugs there. And plotting was a pain to set up. It had no specific plotting routine for it. Documentation, though, I would regard as very good. And SciPy, well, it started in that year, and I found it pretty much useless at that time. So nothing quite worked as well as you would like, but you could always fix things. That was the good part of open source, is you could make it, if you needed something, you could fix it and send in a patch. At that time, you didn't have pull requests. You had patches. We were using Subversion, and I sent in the one-dimensional zero finders at that time because I needed them. And so that was the trick then. If you needed it, you could put it in. That's the wonderful thing about being at the beginning. By the time you get up to the end, you have a lot of barriers. You've got to have review. You have to have tests. But in the beginning, it's much easier. And then I also posted the SciPy constants module to the list, and that eventually made its way into SciPy. I don't know how. Somebody in North Carolina picked it up and got sent around. Anyway, that was basically my start on doing things. And then we had F2Pi due to Pero-Peterson, and that is a very important building block in all this because SciPy interfaced to so many Fortran routines. So that was a very important thing there. It wasn't quite up to snuff in 2000, but by 2002, it was getting quite usable. Later on, we had Pyrex, Fig, and Python, but those are for the C interface. So we have to be fancy, right? We need some pictures, and that's where the first, well, second as it's counted these days. That's where the second SciPy meeting was. This was on the Caltech campus. Breakfast was right through the door in the middle there. And the conference itself was in the room behind the two windows on the right and going down, and the seating capacity was 50. So that was how it began. And when I got there, the end of the campus there, southern end, was completely fogged in. I couldn't find my way, and I wasn't the only one. Conrad Henson was also wandering there, and we ran into each other and tried to figure out where we were. Conrad Henson was the guy who did the complex number implementations for Numeric. You have to remember neither Python nor C had complex numbers at that time. So we eventually got in there, and it was a great breakfast. It had bagels, cream cheese, and a little mountain of lox on ice. Really one of the most memorable breakfasts I've had in these meetings. So, and then after the end of the conference, which was just 2 days, we had a little planning meeting. And Fernando Perez was there. He'd been paid to attend. He was a graduate student in Colorado at the time. Eric Jones paid for his attendance. And boy, he was already busy. He was really working hard. And so at this point, I'd like to point out these sponsors of these first SciPy meetings, because they played an important role. The National Biomedical Computation Resource, the Center for Advanced Computing Research, they helped set up these meetings on Caltech. And of course, Eric Jones at InThought, who is still an important part of the support for this. Also, the Space Telescope Science Institute was involved, but it was a little bit less direct. So those were workshops. The first one, really called SciPy, was in 2004. We had, Jim Huguenin, who is usually credited with Numeric, was the keynote speaker. We had MATLAB presented. Fernando Perez did an Emacs plugin. It's not quite yet Python, but it's getting there. Francis Alted presented PyTables, which is the first HDF5 interface. Eric Hagberg, who is still around, did the Network X. And we had Perry Greenfield from the Space Telescope Science Institute reported on Numarray. Numarray was supposed to be the replacement for NumPy, and Perry Greenfield was the one working on that. And again, the dinner was pretty good. It was steak and baked potatoes at the Athenaeum. My father attended Caltech on the GI Bill back in 1947. And when I told him we were at the Athenaeum, he went, "Ooh." I didn't realize it was a very fancy place. It had a dress code, jacket, and slacks recommended. I wore a T-shirt, so there we go. So, as I said, Perry Greenfield presented Numarray. There was a problem, which was that Numarray was created to deal with very large arrays better than Numeric, but it was slower for small arrays. So we had to decide what to do. You know, should we move to Numarray, or should we stay with numeric? And we really didn't have that many people working on things, right? For example, I wrote new code for sorting in LexSort, and I did that for Numarray. Perry Greenfield put it in, but it wasn't in NumPy. NumPy didn't exist yet. So Travis Oliphant decided to fix this problem, which was really becoming kind of acute, and he went and merged the two, and that came up with NumPy. So at that point, we also moved to a nice auditorium. This is actually my favorite auditorium for SciPy meetings. It's the Beckman Institute. It has a seating capacity of 200. You can see it's much larger than that classroom. It had a nice lawn out front if you needed a nap. And it's really quite nice. I enjoyed that. So 2005, SciPy 2005 is actually one of the ones I missed. But Travis Oliphant presented SciPy Base, which was NumPy. NumPy was originally a part of SciPy, and it hadn't been split out yet. So Travis then split it out. There's usually a little controversy exactly when NumPy appeared, but it was sometime around end of 2005, beginning 2006. And when it was split out, we didn't know what to call it. So you know, when you don't know what the name should be, what are you going to do? You're going to bike shed, right? So we had a good deal of discussion of what do we call this thing. So we finally settled on numerics, and with the joke that it was Asterix's educated cousin. But it turned out that name had been copyrighted by a company in Australia, and we couldn't use it. So we finally decided NumPy, and why? Well, that name already existed. It was sort of an alias for numeric, but not an official one, and we decided to just fall back and use it for the new package. And don't ask me how to pronounce it. I say NumPy because it's what I'm supposed to say, but I think NumPy, right? So that's how that goes. So NumPy was a mix of numeric and parts of SciPy. He had F2Pi, came in from Peru. He'd had it as a separate project, but apparently didn't want to pursue it separately after that. Disutils, which is a very important part in the beginning. That was Peru Peterson and also Travis. Travis stuck in a polynomial package. Random numbers are still not quite up to snuff, but Robert Kern had improved them. Mostly we inherited the linear algebra, which is already pretty complete, and FFT-Pack, which was also inherited from numeric, and mask arrays, which are also inherited from numeric. So it was really a mix, and I think it was mostly indexing and such that came in from Numarray. Okay, so also when that release came out, there was a preliminary documentation standard for how we should document, but it didn't work. If you used it, things looked terrible. You had big titles scattered all over the page. It was just ugly. So we discussed. At that point, people tried to start documenting, and there was a good deal of discussion of setting it up. And eventually, that did get settled after about a year of discussion, and that was the NumPy format. And Polly Vertanen, who will turn up more later, he was named One Man Army by Stefan van der Walt because he was so fast. He wrote a Sphinx extension for the new format, and we now had a way of documenting our functions. And in the year 2008, we have the documentation marathon. Some of that was funded through University of Central Florida and Joe Harrington. Polly Virtanen set up an online documentation editor, which was widely used by DocWeb. And that documentation server was initially hosted on Gail Verquo's girlfriend's computer. So that's a story on that. And a large part of the documentation was done at that time. My big contribution there was inventing the term array-like, which if you think about it really doesn't mean much since everything can be an array, but it's more of an intention than a thing. And I also, as I went through, I was doing documentation, and some things I put off a little bit, and I wrote blah, blah for the documentation. Of course, it came back to bite me. Fernando Perez was demonstrating NumPy's documentation in a presentation, and guess what came up? Blah, blah. Boy, was he motivated. So, SciPy 2008 was the first one we had where we had proceedings. Mostly we had had technical talks before then. We decided to branch out, and the proceedings were also supply some credit for people who presented. That was work. You had to review people's presentations, and so it was extra work. But the thing I really remember, since that was at the end of our documentation marathon, was wandering around the Caltech campus late at night with Travis and a group of people. We were looking for a room to discuss documentation. And I'm surprised we didn't get arrested. So the other thing, we had good restaurant recommendations from Robert Kern, who had attended Caltech years earlier. And he was our restaurant guide. He could tell us where to go. And the other thing I really remember is we were debating who would graduate first, Stefan van der Waal or David Cornepoo. And so David was doing an incredible amount of stuff, and we figured there's absolutely no way he would graduate first. It had to be Stefan, and we were wrong. So the other, one of the most memorable SciPy I remember was 2009. This is the last one on the Caltech campus. And we had almost everybody there that I was familiar with. We had Polly Virtanen from Finland, David Cornepoo from Japan. He's French, but he was in Japan. Stefan van der Waal, who was in South Africa at the time. Gail Verquo, who had spending time in the U.S., but he was French and also associated with scikit-learn. Dag Schvelboten, I'm not sure of that last name, from Norway, and Anne Archibald from Canada. Anne Archibald was the one who did the KD trees for SciPy. And it was quite nice. We had had discussions in the quarters of the hotel at night. It was everything these meetings are supposed to be. And then things changed. Travis Oliphant became president of InThought in 2008 and sort of faded out of NumPy development at that time. 1.2 was the last one he was really intimately concerned with. And you can see that in the top 5 committers from NumPy from 1.2 to 1.5. You see David Cornepoo up top. That's why we didn't think he would graduate. Polly Virtanen's there. I'm there. Pierre GM was doing a new implementation of masked arrays. And there you see Travis Oliphant. So he was busy now being president. And so there was a transition. Now, that's sort of a dangerous point in these projects. If you have one guy who's dominant and he leaves, it could very well collapse. So I think we were a little bit lucky, and the three of us were able to take it forward after that. So what did we do? We did we released NumPy 1.3 to 1.5, and Python 3 had come out. I had asked at the conference how many people were using it. About 5 people raised their hand. And so we had to get started, and we made that transition so that NumPy and F2Py, which we needed for SciPy releases, were Python 3 compatible. That again is sort of another critical point. If we'd missed that, we would have fallen behind. We also broke up the files inherited from Numeric. They were big, enormous files in there, a couple of them. We broke them up into functional units. Pretty much what you see if you go look at at GitHub today. We broke those up. I wrote new polynomial classes. Pierre GM did the new mask array implementation in that period. And we also finally got nose testing done mostly by Alan McIntyre. So we made quite a bit of good progress, and David Carnapoo was being release manager until the last release, 1.5, at which point we suckered Ralph Gommers into doing the release. So he volunteered, poor guy. And there we were. So at that time, this was a SciPy first one in Austin. That was 2010. We had a meeting to decide whether we should move from Subversion, which we had been using, to GitHub. And we had waited that long because we wanted to make sure that GitHub had good support for Windows development before we did the move. So we decided to give that a try. Polly Vertanen did the conversion, so he did the hard work there. And we actually, before doing that, we checked with Ralph if he was all right doing a release from GitHub. And he said yes, and there we went. So we're now on GitHub. That made quite a bit of difference on development. It's much easier than taking patches out of emails or just well, it's not easier than just putting the stuff in, which is what we did before, I like this, top, it's in, no review and stuff. Okay, so at that point, that Three Musketeers sort of dispersed, and I was actually burned out. It was more than I could handle. I wasn't sleeping well, and then Mark Weeb showed up. So he showed up in November 2010, but was really most active in 11 and 12. And I felt great relief because it was apparent that he really knew what he was doing. So here's what he did in 1.6 and 1.7. He added the float 16D type, which has become important for AI and stuff. He created einsum, which has become an important tool. He made date time work, which wasn't working before, and added calendar functions. And if you've ever fooled around with time, it's a mess. You can't figure out, what does time mean? Which clock do you use, and so on. He added the where and keep dimension keywords to ufuncs. He created the new array iterator, which we've been using since. He improved the type promotion. And last, he made bit mask part of end array. Now, arrow validity arrays are that same concept, somewhat later in time. But that particular thing was controversial at the time, not least because it changed the basic structure of the ND array on the C level. And so that was taken out before the 1.7 release, and we don't have it. So that was sort of the end of that. Mark went on and worked at Anaconda after that. But that was sort of the end of his time at NumPy. So the next step up was we needed a governance document. We needed that in order to solicit funds. I mean, you can't just go up the door and say, give me money. You've got to have some legitimacy, and part of that is having a governance document. So we sat down in SciPy 2015, and we tasked Nathaniel Smith to write that document. He got that done, preliminary versions, at the end of 2015. We had both that and the code of conduct. And so we were then ready to move on. So at that time, let me just sort of go a little sidetrack here. This is on distribution. Now, previous to this period, we were releasing on SourceForge. There might be 5 files. There would be maybe 2 for Windows DMG, maybe 2 exe files for Windows, and a source file for Linux. So that was, that's just, you look at now where they're doing millions of downloads per month from GitHub for downstream projects to test. You can see that's not going to work very well, especially with the Linux being a source release. So that started to change in 2013 with the wheel binary package, that's wheels. Initially, the wheels were just Windows and Mac. And so that helped a little bit, but not a lot. The problem with the Mac is that you have all these different Mac Linux distributions, and they all have different library versions, different compiler versions, and so it's hard to release a binary for that works for all of them. That was solved in PEP 5.13 with Mini Linux 1. I think that was one of the major steps go forward on distributions. And I just mentioned the last NumPy release. On PyPy, we had 50 wheels. I expect by the time that Python 3.14 comes out, we'll have over 60 wheels up there. It's actually getting kind of out of hand there. But you can see what a difference. If you download, you don't have to compile NumPy. You just download the binary and run it. And then we finally got some funded developers. This is in 2017. Bids got they actually went out and got the postal solicited 2 grants. They got grants from the Moore Foundation and the Sloan Foundations for NumPy development. And they hired 2 new developers, Matty Pickus and Tyler Reddy. These were the first 2 paid developers for NumPy. So what difference does it make? Well, you look here at where 2018 is, where it starts to go uphill. And you can see that the number of merged PRs and commits has gone way up since 2018. So it made a big difference, and it sort of let me also sort of slip out the door and start to retire. So that helped. And now, about the same time, we ran into the problem, like we had the problem previously of Numarray and Numeric splitting the community. This has come up again because we have all these NumPy-like projects out there. We have JAX, PyTorch, Dask, QPy, X-Ray, and they were not quite compatible. So again, you're splitting the community. It makes it hard to develop. And also these things were driven by the needs of AI, in particular GPUs and distributed processing. So, what to do? We certainly were not in a position to handle all these different applications. We had neither the expertise, nor the money, or the people. So we decided instead to move for interoperability. The first steps here were array U-funcs. These were first proposed by Pali Virtanen back in 2013. Sort of got delayed, but they came out finally. And then we had array functions, which was an extension of that, and mostly driven by Martin Van Kerkwijk, and that allowed overriding array functions. Now, this isn't a final solution because it's just you have to override and use one array implementation over another, and it's just a kind of a mess. But it did stop the initial split. It demonstrated the virtues of being able to interop, and that was good. The first ones I remember are Dask and KuPy demonstrating that interop operations. So they helped. But in the long term, I think we really need to have the array API standard, which came out a couple of years ago. And I think this will do a good deal to unify the community. It's versioned, it will come out yearly, and I expect it to slowly grow to cover a great deal. Okay, next step here is we dropped Python 2.7. We thought this might be controversial, but it wasn't. We dropped it a year early. Python itself was going to drop it in 2020, but we needed C99 compilers. And since Python was released with certain compiler versions, 2.7 on Windows was released with a very ancient compiler version of MSVC, and it was blocking us from moving forward. We really needed C99 compatibility. So we finally dropped it, and it was quite wonderful. We could immediately move forward with a couple of things. The first one was a replacement for FFTPack. This is by Pocket FFT that improved. FFTPack was somewhat limited. You needed, if you wanted good performance, you needed to have this length of the array being transformed, had to be made up of products of 2, 3, and 5, and I think maybe 11. Anyway, it was limited. If you didn't have that, it got very slow. Pocket FFT was a big improvement there. And then, not directly due to that drop, but we had the new random number generation implementation due to Robert Kern and Kevin Shepard. And I'm actually quite impressed with that package. I think the design was state-of-the-art at the time. It's designed with an eye towards parallel execution. Which makes a difference, you know, when your desktop computer has 64 CPU cores on it, you like to be able to make use of those. And since a lot of use of random numbers is just simulations, it's trivially parallelizable. So that, I think, was a great bit of progress. And finally, recently, NumPy has moved to Meson for building. Ralph Gummers was primarily responsible for that move. It was needed because we were to use setup tools, which we were doing before. We really needed distutils. Our distutils were derived from the Python distutils, And Python disutils went away in Python 12. So we needed another build system. So this is a big change. It's faster. It's a little more flexible. And the nice thing is it removes the maintenance from NumPy itself. This is something that's nice to have as somebody else doing the work, and you can concentrate on your core. Okay, so that was the end of Austin there in 2023. And now here we are at the Tacoma Convention Center. And I put a picture in just so to be consistent. And NumPy 2.0 has been released last year. What did that do? Well, first of all, we had the Array API out, so we updated a lot of functions to be consistent with it. Same with promotion rules for Array API compatibility. D-type handling was improved for extensions. That was mostly due to Sebastian Seberg. API was changed and we removed outdated functions and duplicate aliases. Basically a cleanup, which is bound to break some people downstream. That's one reason to going to 2.0. The ABI was changed, and we also finally got arrays with variable length strings as elements, and that was done by Nathan Goldbaum. So I think it's actually kind of remarkable that all these years later, NumPy is still under fairly heavy development. But that's life. It's driven by hardware and other things. So what have we accomplished after all this time? I certainly had no idea that we would have as much impact as NumPy has had. All I wanted was something I could use for myself, right? It was very selfish there. I was not driven by big dreams. But I think that may be important. I think NumPy is really, in many ways, a service to the scientific community. And it is important that it serve the people who use it. And I think having an open source where they can make contributions and open issues is an important part of that. Going forward, of course, there are a lot of things people could use instead these days, but it is still free, easily available, and fairly lightweight. Now, I think NumPy itself may fade in the future. Nothing's immortal except for COBOL, and I don't think NumPy is an exception. But I think the Array API and the idea of a universal computational ecosystem for science, I think those are important, and I think those will persist. And I think that may be the greatest accomplishment, even if NumPy fades from the scene. And that concludes this little trip.
Thank you so much, Charles, for your wonderful keynote. I'm going to encourage people to ask questions in the keynotes channel in Slack. I've started a thread there. Please also give like a thumbs up reaction or something, or an emoji reaction to questions that you think are interesting. I will prioritize them based on kind of what people's interests are. Okay, so our first question is from Nodar. So what were the dominant high-level, i.e. higher than C, Pascal, and Fortran languages used for scientific computing during 2001 or so when you were first, the beginning of your talk? And what do you think is the reason Python specifically caught your and others' attention?
Well, part of it is I'm a sucker for shiny things, right? So not everybody wants to try new things. I was a sucker for that sort of stuff. I liked the language because it was very clean. It was very simple. I had gone earlier, I don't know if you're familiar, but there was a time when code was not formatted. It was all Fortran, it was all lined up. You had go-tos, you didn't have indentation. I remember that transition in the 70s, and it was controversial. It appealed to me that was built into Python. So that colon, the indentation that people complain about, I loved it. I thought it made it look pretty and easy to read. And it was almost like pseudocode. You know, you didn't have to type everything. Of course, you have to these days, but you didn't have to. So it's just a very pleasant language to work with. The facilities for working with it weren't great. IPython eventually fixed that. All these things got better over the years.
Thank you. Our next question is from Ed Rogers, who asks, what are you hopeful about when you look at the next 10 years of scientific computing in Python?
The next 10 years, I have absolutely no idea. No, quite seriously, I don't. The number of projects out there is actually quite mind-boggling, but I notice they don't all use NumPy. For data frames, I notice Arrow, for instance, and Pandas, and a couple of other things are out there. So I'd really hesitate. I mean, computational power keeps increasing. Of course, we have AI. I don't know if AI is going to write programs decently anytime soon, but it's certainly a possibility. So I'll just say I don't know. Just keep an eye on it and see where things head.
Nick Hartman asks, what is your advice on managing the scope or focus of a Python package over decades, especially as it's evolving?
You know, I don't know that it's really been managed that much. On NumPy, there's usually only about 2 or 3 active people at a time. So management can be very much just discussion and decisions. You don't have to go through a lot of voting and such. So I think the one important thing about NumPy is that the tone has always been very nice. The conflicts have been minimal. There have been some. I left them out. Did not figure it was relevant to the celebration. But there haven't been many, and by and large, we're decent people, I think, and behave well. And I think that's an important part of making that project work. Does that sort of cover the question, or?
Yeah, although you can definitely talk about conflicts. Okay, so Ryan Cooper asks, what are the cyclical patterns that you've seen in the development of scientific computing code? Is there something that you see coming based on current trends?
I'll have to pass on that. I don't really see a cyclical pattern.
Okay, yeah, that's totally fine. Tim Sweeney asks what your thoughts are on the Arrow project. You just mentioned it. Do you have any deeper thoughts on the Arrow project?
On which?
On Arrow?
No, I don't, except I'm kind of pleased that they have the validity arrays, because that was sort of one of the things I liked that we don't have. Wes McKinney, of course, did both Pandas and Arrow. And I think Arrow is better suited for applications that are column-oriented. I don't think there's any question about that.
Thomas Fan asks, how feasible is it for NumPy to use CPython's limited C API so there's fewer wheels?
Excuse me?
Thomas Fan asks, how feasible is it for NumPy to use CPython's limited C API so there are fewer wheels?
I think we're headed there. So I think it's feasible. I think, but nobody's really working on it at the moment, but it could happen. Yeah.
Okay, Cody Cruson asks, and it's sort of, like you've been talking about NumPy, which is so broadly applicable in many scientific domains. And so Cody asks you, what are your thoughts on focused science field packages, like packages for domain-specific packages and their leadership structures?
So I'm not quite understanding the question here. So what is...
Yeah, I think maybe it's like I don't know. Maybe it's like sort of comparing, a package that's broad versus something that's very domain specific. Maybe like SciPy.
I still don't quite understand. Now my hearing might be going a little.
No,
bit
it's
here.
okay. Can you comment maybe on just the different approach you might take for a broad package like NumPy versus something much more domain-specific like SciPy?
I think it's just user-driven. If you have a domain, you write something specific to your domain, I think that's fine. You could argue COBOL is a domain language, and that's why it's still around. Fortran is a domain language, and that's why it's still around. So there's nothing wrong with having a small project that does precisely what you want to do. You don't have to think big. You just have to think useful.
Okay, so we have Sneakers the Rat asking, given the emergence of many NumPy-like packages, you talked about this sort of expansion that we're seeing, some of which are developed by open source groups and others by companies and have different needs and expectations. What do you see as the needs for governance to keep the ecosystem of tools free and open, and what are the threats to that ecosystem?
So I'm hesitant to try to put together any sort of governance for the whole. Everything is still developing rapidly. I think it's good for people to go out and try things, even if they're corporates. And so these tools are definitely competitive, and they're better in some ways for some particular applications. That's why I emphasize that NumPy does have some advantages. Relatively, it's fairly lightweight. I think it's good for a lot of everyday uses. But I would hesitate really to try to fit everybody into some sort of governed organization. I think it's too early, and I think it would stagnate things.
Okay, well, we're getting close to time, so I'm going to ask the last question now, which is from Ariana, who asks, it sounds like you've had such fond memories of specific contributors and events. Can you speak more about the role of community in your work?
Which groups?
Just like throughout your development, you have worked with specific contributors, and you've talked about the events that you really enjoyed throughout your time. So can you speak more about the role of community in the work that you did?
Well, the community on one of these projects is a little bit odd. First of all, it's fairly small at any given time. Second of all, it's split all over the world, right? Mostly between Europe and the US at this point, but we're starting to see more from other places. So it's mostly an online community. We do get together occasionally, but that's why I emphasize the SciPy 2009, because really everybody was there, everybody really involved. That's not usually the case. Face-to-face time is great, There were some other meetings that were smaller, run by bids, which were very nice. I enjoyed those. You need the face-to-face time, but you seldom get everybody together.
Yeah, it's wonderful to get to see everyone. And so, you know, when we get it, it I think really makes a big difference. Okay, let's thank our keynote speaker one more time.